Hi all, this is Srikanth. In this video, we will understand what is OIDC exactly and how does it work. OpenID Connect is an authentication layer built on top of OAuth standards. This facilitates the exchange of user information between third-party IDPs and the client application, thus enabling the authentication. So to securely transfer the user information between IDP and the application, OIDC uses JSON Web Tokens. So OIDC lets users log into different applications using just one set of login details from trusted providers like Google, Facebook, or Microsoft. So let's take a look at the real world example and see the OIDC in action. So imagine we are trying to log in into an application like Spotify. So for this demonstration purpose, we will consider Spotify as a demo application. And this application allows users to identify themselves using different identity providers like Google, Facebook, or Microsoft. So after selecting to continue with Google, the user is taken to the next screen where they are prompted to enter the credentials. The next step is authorizing Google to share the necessary identity information with the Spotify account. And after this, the user is redirected back to the application. Okay, so let's understand this with an example, how this is done. So let me navigate to the application. And I'm trying to access the Spotify login account. And this is the login page of the Spotify. And over here, the user is prompted with a different login options like continue with Google, continue with Facebook, and continue with Apple. So user has a flexibility to choose any of the login options and proceed with the authentication. So for this demonstration purpose, we will continue with Google. So before continuing, I would actually enable the network panel, and I would like to understand what kind of flows are happening between the application and the IDP. So I'm clicking on continue with Google. And over here, I have given an option to enter the Google details. So this is the Google account details, and I'm trying to log in. I'm entering the password. Now the login is successful and the user got logged in. Okay, so behind the scene, there are many calls which actually happen from the application to the backend server. But over here, what we are interested is about the scopes and few of the parameters which are actually passed from the application to the IDP. Now, if you see the request response, right? So the user, the application is actually requesting for few information in the URLs. So one is the client ID, and the other one is a state. And the other one is a redirect URL and the scopes. So these are a few parameters which the application is requesting to the IDP, and the IDP is responding back with the information to the application. So after successful authentication, the user is logged in, and in this session, the user will be generated the access token and the ID token. Okay, so we will try to understand the flow and how the flow is happening between both application and the IDP. So the OIDC authentication process typically follows these steps. The end user tries to attempts to access a protected resource, and the application redirects the end user to an OIDC provider for authentication. Here, the application is Spotify account, and the OIDC provider is Google in our example. And the end user authenticates with the OIDC providing his credentials. So we just authenticated with the Google credentials over here, and the OIDC provider generates ID token and access token and sends it back to the application. And this application verifies the ID token and grants the end user access to the protected resource. So this is the flow, how the how the flow is happening between the application and the IDP. Now let's try to break down the flow into much granular information, and we'll try to understand what parameters are sent from the application to the backend IDP, and what information is sent from IDP back to the application. Okay. Now for that understanding purpose, we will navigate to OAuth Playground. So OAuth Playground actually gives us an option to decode the flows that are happening between the application and the IDP. Now, for the demonstration purpose, we have to create a sample application, and the sample application will be acting as an IDP in our case. So I'll navigate to OpenID Connect, and in the OAuth Playgrounds option, there is an option to create or register a client. Now, for the demonstration purpose, I'm registering a client. Now this is a dynamically generated client, so this will have a client ID and secret, and a demo user account with a demo login and demo password. So for the records purpose, I will be saving the information of both user ID and password, and I'll continue with the flow. Okay, so at the end of the OpenID Connect process, the client ends up with the ID token, which contains the information about the user who signed in. So this token is encoded and signed, and the client is expected to pass it directly. So in this example, we will cover the OpenID Connect authorization code flow and request an ID token as well as the access token. So before authorization begins, it first generates a random string to use for the state parameter, and the client will need to store this to be used in the next step. So if you see, there are a few parameters which are sent as part of the request. One is the response type, client ID, redirect URI, scope, state, and the nonce. These are the same parameters which we just saw over here in the Spotify account. You can see that the scope is sent, redirect URI is sent, and the client ID is sent, and the state is sent. So the same parameters which are sent as part of the request URL. Now, if you try to understand the significance of these parameters, response type, so response type is equal to code, will let the IDP know that application expects an authorization code. Okay, and the next parameter is a scope. This parameter basically defines the limitations in accessing the resources. It can be OpenID scope, email, or any other parameter that we are expecting from the IDP to be sent back to the application. And the next parameter is a state. So this is a string randomly generated and passed back and forth with the IDP. So by passing the string, both IDP and application knows whether they are speaking to the same device between the communication. And this is basically used to avoid a cross-site scripting attacks. And the final one is the redirect URI. This informs IDP which pre-configured URL to redirect back to the application. Okay, so let's continue with the demonstration. Over here, these are the request parameters that are sent in the URL, and I'll try to authorize this. And during authorization, I was asked for the user login information. It is the same screen which Google would ask, but in our demonstration, it is the OpenID OAuth dummy application, which is asking for the username password. And I'm entering the user details over here, and I would like to authenticate to this application. Now, over here, you're seeing an option saying that this will share your name and email address with the application and will let the application access your photos. This is because we are actually requesting a few attributes in the scope parameter. That is why it actually trying to get the information from the IDP. Now the login is successful, and the next state is that verify the state parameter. So in this step, the user was redirected back to the client, and you notice that a few additional query parameters in the URL. So you need to first verify the state parameter. Over here, this is used to avoid cross-site scripting attacks. You can see that the state parameter that was sent from the client and that was sent from the IDP, both should be matched. So the state is basically a randomly generated string, and this is actually passed back and forth with IDP. So by passing this string, both IDP and application knows whether they are speaking to the same device between the communication, and this is basically used to avoid the cross-site scripting attacks. So since the state is matched, I will continue for the flow. And in the next step, we would be exchanging the exchanging the authorization code for the access token in the back channel communication. Over here, as a response, we would get the code. So this particular code we received from the IDP, and this would be exchanged in the back channel communication to get the access code and the ID token. So let me go ahead and perform the exchange operation. And over here, the exchange is success, and we were able to see the ID token for the user generated. Okay, so now your application can use the access token and ID token to make API requests on behalf of the user. Now, let us try to decode the ID token and see what is there in this ID token. Yeah. Now I'll navigate to JWT decoder. And if you see, this is the decoded information of the token. So the user information like the username, email, and other attributes are part of this ID token. Okay, so basically the OIDC provides a secure and efficient and user-friendly way to manage digital identities. So it simplifies authentication for users while enhancing security and streamlining user information for organizations. So it's an open standard, and this is the best approach which ensures interoperability and makes it a versatile solution for a wide range of applications. Thank you.